And here's the content. Today we're going to talk about several things, and they all involve matter. Matter makes up all living things in the universe, and it's all made of atoms. Now, not everything in the universe is matter. I mean, you can have some non-living things that are matter also, but the things that are not matter are things like light and sound. Matter must have mass and take up space. If it doesn't take up mass or space, then it probably is nothing. But matter takes up mass and space. Now, all matter is made of atoms. An atom is the smallest basic unit of matter. So small that even the best microscope cannot see one individual atom. To kind of show you, 1 teaspoon of water like this, or maybe even filled up a little bit more, would have about this many atoms in it, 5 times 10 to the 23rd power. And you know that's a lot of zeros after that 5. That's just staggering to even think about. Now, an atom is kind of like an H in the H2O. Here we have the H2O molecule. We have an oxygen molecule and 2 hydrogen molecules, an oxygen atom and 2 hydrogen atoms attached to that. Whenever you have 2 or more atoms combining, that's when you have a molecule. 2 or more atoms combining. Like right here, we have 3 atoms that make up a simple water molecule. Now, we have the hydrogen, hydrogen, and oxygen. If you were to break this molecule down, take one of these 3 parts away, it would no longer be water. It would just be whichever atoms are remaining. So a molecule is the lowest portion of some given substances that are combined from atoms. You can kind of say atoms are like the building blocks of molecules. Now, most molecules are not as simple as this, and I have an example right here. Here we have an oxygen, an O, several C's, several H's. That's kind of what most molecules look like. If you break this apart, it's not going to be anymore, looks like propanol. It's not going to be that anymore. It'll just be a combination of a bunch of different atoms. So here we have a lot of different atoms, but only one molecule. Now, if you were to add more atoms, say to this one, you have the H2O. If you were to add, say, an oxygen, it would completely change what you have. H2O2 is no longer water. It is hydrogen peroxide, and some of you may be familiar with that. You do not want to really drink hydrogen peroxide. It's much different than water, even though it actually looks pretty similar, but it is a different substance. So in molecules, you can't just add and take away different proportions. Every H2O molecule you have has to have the 2 H's and the O, and you just kind of build upon that. Okay, some scientists believe that all matter is moving. The gases are moving, the liquids are moving at a molecular level, and yes, even the solids are moving. The pencil or pen in your hand, even though it doesn't look like it's moving, all the atoms in there are vibrating. Same thing in the liquid. If you were to drop a drop of dye in liquid, it doesn't just puddle up there at the top. It eventually swirls around and becomes immersed throughout the whole liquid, because all the molecules are in fact moving in there. Unlike solids, the liquids can move a little more freely. The gases molecules can move a lot more freely. They're moving around all the time. But yes, even a solid, scientists think, is moving. The desk in front of you, for example, would be moving. Now let's talk a little bit about mixtures. Most matter is a mixture of molecules. Paper, air, wood is not just one hydrogen or one oxygen. It's all kinds of mixtures of substances. Even drinking water. besides the H2O, has minerals and chemicals that have combined with it. A substance is pure if it only contains that one type of molecule. We mentioned a molecule earlier, the H2O. Now, I just said that H2O is usually not in its pure form because you have minerals and chemicals in your drinking water. But if you were to have H2O, H2O, and nothing but H2O, it would be a pure substance. But you can imagine that doesn't happen very often in nature. You tend to have a lot of mixtures. One pure substance would be a bar of gold. A bar of gold would have nothing but this element gold here, and it happens to be number 79, signified by AU. But that would be one example where you would not have the mixture. But most everything would be a mixture of the elements. The elements here, well, here are the listing of elements. You see these 114 or so elements right here. These are the elements known in nature, and some of them are actually elements that are man-made, but scientists put them on this periodic table anyway. But an element contains only one single type of atom. You cannot split an element up and still have that element. Here we have hydrogen. If you were to split hydrogen up further, it would just be atoms. You would not have hydrogen anymore. And all our compounds come from these elements. So elements are building blocks of compounds. Compounds like the H2O, here's the O. Salt is going to be NaCl, here's the Na. Cl should be over here, yeah, here's the Cl. So all of these build all the compounds that we have. Now, a compound is two or more different types of atoms, water, salt, and many, many different other kinds. Note that the combination of the two is usually nothing like the compound itself. Like hydrogen here is a gas. Oxygen here, it's a gas also, but hydrogen and oxygen form to make a liquid, H2O. So that happens quite often. Now, most of the time you're going to get a mixture. Like I said, there are a lot of mixtures in the world because it's hard to find pure substances. Hard to find those pure compounds or things that are just the elements and haven't mixed with other things. A mixture is a combination of different substances that remains the different substances. It's kind of like an ice cream sundae. You can put all kinds of stuff on an ice cream sundae. You can put sprinkles, you can put a cherry on top, you can put cookie dough on it, but it's still those different substances. By putting a cherry on top doesn't change what it is. You could add things, you could take things away, and you still have an ice cream sundae, and all the different parts are still all their different parts. It's not like H2 and O, not like H2O. In H2O, once you add the two H's to the O's, it changes it. So a compound you cannot split up and still have the compound. But a mixture you can split up. Now here we have, down here, we have compounds down here. The N and the O, compound of nitrogen and oxygen, CO2, compound of carbon and dioxide, but that's not like this. Here we have this mixture. Don't know what this is, just general something. Here we have this mixture, but you can separate the mixture into the reds, into the greens, into the yellows, and into the purples. But if you were to take a compound, you couldn't do that. Here's a compound, H2O, but if you take away one of the H's, it's different. It changes it from water to something else. Now over here we have a mixture that can involve, it's the air. The air has nitrogen, which is an element, oxygen, which is an element, and CO2, which is a compound. So you can have compounds in your mixtures even. So seawater is a mixture. A mixture and a compound may seem similar, but they're not. Mixtures can be separated physically, just like it was here. Compounds can only be separated at a molecular level. And the proportion of mixture can be varied, but in a compound it's not. Here, if you want to add another red little jelly bean thing, you can. If you want to put another sprinkle on your sundae, you can. And it's not going to change the anything else. But here, if you have two H's and an O, and you add an O, and it's a completely different substance. So that's the difference between a mixture, like here, and a compound, like here. Now, speaking of mixtures, if you have a handful of soil, you may have more pebbles in one section of it. You may have more sand in another section of it. You may have more different stuff on this side, and let me get a different color. You may have different stuff on proportions on this side than you would in the middle, or different proportions than you would in here. It's all mixed up, but it's not necessarily going to be the same everywhere you have it. And soil you get from here in Georgia is probably going to be a little bit different from soil you get in other parts of the United States. Another handful from a different country may even be completely different. Those are called heterogeneous mixtures. So when you have a heterogeneous mixture, it is not spread throughout. They have different type proportions. That's opposite to a homogeneous mixture. A homogeneous mixture here is kind of like this Kool-Aid. It's spread evenly throughout, kind of like sugar dissolving in water. You have an equal ratio of sugar as you do to water. Here in this Kool-Aid, if you were to take a sip, this first little sip here, it would have the same proportion of stuff as if you take a sip that's down here, or a sip that's down here, or even one of the last sips there is. So that would be called a homogeneous mixture. Hey, hope you've learned a little bit about the difference between mixtures and compounds.